All right, guys, I'm going to get through as much of this as I can. But like I just said, I promise, I will put the entire review, all the answers up on Canvas for you guys to check by this afternoon. I just want to check mine against Miss Glick's to make sure we have the same answers. There are 9 questions total, but there's a question like these first ones. That's more than 9 questions. You know what I mean? So there's 9 actual number 1, number 2, number 3, but some of them have different things and more things inside of them. So what I want to remind you of, please, let's write this down. Things you need to remember. All right, standard form of our quadratic is ax squared plus bx plus c. C's your constant, right? Our vertex form is a times x minus h squared plus k, where h and k are your vertex. What's your vertex? So you're going to have questions that give you your equation in standard form, and you have to write it in vertex form. Right? Remember that vertex is what tells you so much about your parabola. How do you find the vertex when you're in standard form? It's x equals negative b over 2a. Once you find that value, you plug back in to find your y. All right, so let's do these first 2 together. Just looking at this problem, there's a bunch of stuff we can already fill in. First off, which way does this parabola open? How do you know it opens up? Because A is positive. Good. I know it opens up. I know that my axis of symmetry is going to be at what letter? X equals. You have to have that. I know that my maximum or minimum point is going to be at what? Y equals. Does this parabola have a maximum or a minimum? How do you know it has a minimum? Because it's opening upwards. There's a point that it doesn't get any further down. Good. What is the domain for every single parabola that we're going to talk about right now? Negative infinity to positive infinity. Good. You don't know the range fully yet, but you do know that this opens upwards, right? So is your range going to be from down here at negative infinity to the y part of the vertex, or from the y part of the vertex to positive infinity? So it's going to be from the y part of the vertex, whatever that is, to positive infinity. All this stuff you know just by looking at your equation. Yes, ma'am? Because it's always the vertical line that cuts the parabola in half, so it's going to be the x part of the vertex. And then you can tell your y-intercept just by looking. If you plug in 0 for all your x's, you get negative 3. Your intercepts, guys, need to be written, as ordered pairs. So 0, negative 3. Your x-intercept needs to be an ordered pair. You have to write them as ordered pairs, but it's just your constant. All right, so now we go through and we're like, well, okay, we got a decent amount of stuff answered. Let's find the vertex. That's the main thing to figure out the rest of our stuff. My vertex, to find the x part, I say x equals negative b over 2a. What is my b term? 1. So I have negative 1 over 2 times 2, which gives me, so negative 1/4. That's the x part of my vertex. The x part of my vertex is at negative 1/4. That means I also just found out what? Your axis of symmetry is at x equals negative 1/4. Now, how do I figure out what the y is? I plug in. Yes, you guys are going to have to plug in fractions. You'll be okay. So 2 times negative 1/4 squared minus 1/4 minus 3. Now, think about this, guys. When we evaluate this, this 2 goes to the top and to the bottom. So what's negative 1 squared? 1. And then what's 4 squared? 16. Okay. Then I have minus 1/4 minus 3. Everybody with me? Okay, so what happens here? Can I simplify it all? Not yet? A little bit, can I? Does 2 go into 16? Yeah, 2 goes into 2 once, right? And 2 goes into 16 8 times. So I have 1 over 8 minus 1 over 4 minus 3 over what? 1. All right, no big deal. We have to get a common denominator. What's the common denominator? Common denominator between 8, 4, and 1. Okay, good. So if I change 4 to 8, I multiplied the bottom by 8, so I multiply the top. Multiply the bottom by 2, so I multiply the top by 2. What's negative 2 times 1? Right? Over here, to go from 1 to 8, what do I multiply by? 8. So if I multiply the bottom by 8, then I multiply the top, and I get this. Yeah? Okay. So I have 1/8 minus 2/8 is what? What's 1 minus 2?
1.
Negative 1 minus 24. Negative 25 over 8. Now, I am not asking you guys to graph. So the other part of your vertex is negative, what do we say, 25 over 8? Okay. What else did you just find when you found that? Your maximum or minimum, so negative 25 over 8. Where else does that go? At the range. Negative 25 over 8. So once you find the vertex, you found almost everything. The hardest math you had to do there, guys, was honestly add and subtract fractions. Now, if we're going to find x-intercepts, how do we do that again?
Put the y equal to 0.
You put the y equal to 0, which means you're going to have to do what? Factor. So you have 2x squared plus x minus 3 equals 0. Factoring is never going away. Kind of like my cough. I'm allergic to something. Okay, so we're going to factor. If this doesn't factor, what do we have to use? The quadratic formula. Ooh, gross. Okay, so 2 times negative 3. Negative 6. What are the factors of negative 6?
Negative 2, 3.
That multiply to give me negative 6. And add to give me a positive 1.
3, negative 6.
I'm going to say plus 3 minus 2. What do I have to do now? Divide. Good. Divide everything by 2 because A is not 1. Does 3 divide by 2 pretty? No, so it just becomes 2x plus 3. 2 divide by 2? Yep. And then what do I do to each of these pieces? Set them equal to 0. So 2x plus 3 equals 0. X minus 1 equals 0. So guys, if I move 3 over, it becomes negative, yeah? Divide by 2, I get x equals negative 3 over 2. Move 1 over, I get x equals 1. You have found the intercepts. How do you write them as ordered pairs? Negative 3 over 2 comma 0 and 1 comma 0. Good. All right. Any questions? All right, I'm going to do the second one. I'm going to run through it a tad bit quicker. The math is a little easier on this one. But this one's different. Which direction does this parabola open? It opens down. How do you know this opens down? Because A is negative. So this tells us a lot. I already know that my axis of symmetry is x equals, and I know my maximum or minimum is y equals. Is this a maximum point or a minimum point? Maximum. Okay, I know I have a maximum. What's my domain? Negative infinity to positive infinity. Good. What's my range going to be? Negative infinity to the y part of the vertex? God bless you. Or y to infinity? Negative infinity to whatever the y part of the vertex is. And the reason why is because it's opening downwards. It's negative infinity to there, not there to infinity. Do I know my x-intercepts just by looking? No, but do I know my y-intercept? What is it? How do I write it? 0, comma 3. Good. All right, so we filled all that information out just by looking. So now let's find our vertex. X equals negative b over 2a. What's my b term? So I have negative 4 divided by 2 times negative 4, right? So I have negative 4 over negative 8, which gives me 1/2. You guys are like, oh, fraction again. That's okay. If I know that the x part of my vertex is at 1/2, what's my axis of symmetry? 1/2. Good. How do I find the y part? You plug back in, great. So y equals, I have negative 4 times 1/2 squared, right? Plus 4 times 1/2 plus 3. So when we evaluate this, guys, we have negative 4. Remember, this 2 goes to the numerator and to the denominator, so it's times what? 1/4. And then I have plus, what's 4 times 1/2? Ooh, that's nice. What's negative 4 times 1/4? Oop, just negative 1 plus 2 plus 3. We read left to right. You compute left to right. What's negative 1 plus 2? 1. And 1 plus 3 is? So y equals 4. So the vertex, the y part is at 4. What's my maximum or minimum point? 4. Where else does 4 go? In the range. Good. So we found everything that we needed to except now for y-intercepts. So we're going to do what? Set your equation equal to 0. Good. Is it plus 4x plus 3?
Yeah.
All right. We lead with a negative. Guys, you with me? We lead with a negative. What happens when we lead with a negative? Take it out. Let's take it out. So I'm going to take out that negative 1. And I have 4x squared minus 4x minus 3. Don't just jump to quadratic, guys. Try to factor. Are there factors of negative 12 that'll multiply to give me negative 12 but add to give me negative 4?
Yes.
X what?
X, 6 and 2.
Minus 6 plus 2. Perfect. What do I have to do with that 4? Divide both of them by 4 because your A term is 4. Now, neither of these simplify pretty, but they do simplify a bit. So this becomes negative 1 times x minus 3 over 2, right? And x plus 1/2. At this point, you can set each parenthesis equal to 0 if you want. You can rewrite it if you want, negative 1, and then you have 2x minus 3 and 2x plus 1. But we're going to have to solve. So when I say negative 1 equals 0, what can I do with that? Cross it off. Don't worry about it. Now I have 2x minus 3 equals 0 and 2x plus 1 equals 0. So when I move 3 over and divide by 2, I get x equals 3 over 2. And when I move 1 over and divide by 2, I get x equals negative 1/2. So how do I write those two as ordered pairs?
Negative 1/2, comma 0.
Negative 1/2, comma 0, and
3 over 2.
3 over 2, comma 0. Good. It's a lot of work for one problem. I understand that. But you guys know how to do all of this. We've done it a jillion times. All right, I'm going to do 3 and 4. Again, I will post all of the answers. So you'll have number 5 there as well, but I'm going to do 3 and 4 because they're both a little different. When we talk about end behaviors, first of all, what I want you guys to know is I already wrote this in for you. So already written on your test says, as x approaches negative infinity, f of x approaches, and then you have to fill in the box. So as x approaches positive infinity, f of x approaches, you fill in the box. But you have to understand what that means. When it says x approaches negative infinity, what side of the graph are they talking about? The left side. When they say as x approaches positive infinity, what side of the graph is positive infinity? The right. Okay, so let's work this problem out. I have x cubed minus 3x squared plus 2x equals 0. Because we got to find the zeros and all that. Let's talk about our end behaviors first. Is this written in standard form? Yes. So your highest exponent is a, what kind of a number is 3? Odd. So when I think about odd and I think about opposite, you're going to be going in opposite directions. Is this a positive x cubed or a negative one? Positive. So it's going to resemble, the ends will resemble a positive line. Okay, so here you go for your end behaviors. As x approaches negative infinity, that's over here on the left-hand side, where is your graph going? Down. How do we say it's going down? Negative infinity. Over here on the right, this is the right side. We're at positive infinity. What's your graph doing? It's going up. How do you say it's going up? Positive infinity, all right? That's all I need from you guys. I wrote everything out in blue. I need you to fill in the boxes with either positive or negative infinity. Now, when we talk about zeros, we're just talking about answers. What does x equal? In this case, how many answers should we have? 3. How do you know that? Because the highest exponent's a 3. Good. So, if we're going to factor, what's the first thing we do? Take out a common. What do they have in common? X, okay. Then I'm left with x squared minus 3x plus 2 equals 0. Can I factor that more? Yep, you sure can. What are the factors of positive 2 that multiply to give you positive 2 but add to give you a negative 3? X minus 2 and x minus 1. Now we take each piece and we set it equal to 0. So x equals 0, x equals 2, and x equals 1. Those are your zeros. So you guys would tell me for your zeros, x equals 0, x equals 1, x equals 2. If you want to write it x equals then 0, 1, 2, that's fine. Now we talked about multiplicity. What does multiplicity mean?
Is it if it repeats?
If it repeats, do you have any answers more than once? No. So you would tell me, is there multiplicity here? No. Or you could say once if you want to. Is there multiplicity here? No. If you want to say once, that's okay. It doesn't matter. Or nope. Right? All three are fine. But that tells you what's going to happen at those points on the graph. And that's why this is so important for you guys to notice, because you're going to have to graph. What happens when the multiplicity is an odd number of times? 1, 3, 5, 7. Or if you only have the answer one time, what happens at each point? What does the graph do? Does it touch and turn? Does it bounce? Or does it go through? It goes through. Now, why is that important? If you have multiplicity an odd number of times, like if you have the same answer once, 3 times, 5 times, it's going to go through at that point. If you have it an even number of times, like 2 or 4, it's going to touch it and then bounce the other way. And I'll show you in a second. Yep, so I'm going to show you. Very basic graph. Let me show you what I'm looking for. You guys have already identified everything you need. First thing you should do is put your x-intercepts on. So where does this cross? 0, 1, and 2, right? Is that what we found? Okay. What was the end behavior? What was the graph doing at the end? Going up on the right-hand side and going where on the left-hand side? Okay. And then what did you just tell me is going to happen at each one of those points? The graph is going to go through. I don't care how high or how low you go, just make sure it goes through. So I'm going to start down here. It's going to go through 0, then come back down, go through 1, then go back up to 2. If it were bouncing, which the next one will do, I'll show you what that means. Very basic graph. Just what happens at the intercepts is what I need to see. Does it touch and turn? Does it go in the opposite way? And to make sure that you have your arrows in the right direction. All right, let's look over here at this one. First of all, what should we do with this problem?
Put it in standard form.
Let's put it in standard form first. What should come first? The highest exponent. So it should say x to the 4th plus 3x cubed minus 4x squared. If you guys did not put that in standard form first, your end behaviors would be wrong. Yes, if you kept it like it was, you would say it's even, but you would both say it's negative. So look at the highest exponent you see is a 4. That's an even number. That means the arrows are going to go in the same direction. Is it a positive x to the 4th or a negative one? Positive. So both of the arrows are going where? Up. So as x approaches negative infinity and as x approaches positive infinity, both arrows are going in the same direction. They're both going up. Again, I'm going to have the as x approaches thing written out for you. So ask yourself this question. You guys should do it every time so you remind yourself, how many answers, how many zeros should you have? 4. Okay, let's just remember that. If I'm going to factor this, what do I take out first? X squared. Okay. So I'm left with x squared plus 3x minus 4. Okay. Can I factor this more? What are factors of -4? That multiply to give me -4, but add to give me 3. X plus 4, x minus 1. Agreed? Now what do I do with each piece?
That equals 0.
Okay, x squared equals 0. X plus 4 equals 0. X minus 1 equals 0. Now watch this, guys. When you take the square root, which you guys have done a million times, what goes in front of your answer? Plus or minus. Okay, what's the square root of 0? Is there such thing as a positive or a -0? No, but why is it important that you remember that it's plus or minus? What does that mean? How many zeros do you have? 2. Okay, that's a big deal. Somebody asked me last period, what about if I had x squared equals 4 and I took the square root? What are your two answers here? Plus or minus 2. Is positive and -2 the same spot on a graph? No, there's no multiplicity there. But there is multiplicity when you have 0. It's a special case, so just be aware of that. So here I have x equals -4, and I have x equals 1, right? So when I write out my zeros, you can write 0 twice if you want to. You don't have to. I have x equals 0, x equals 4, and x equals -1, right? So tell me about the multiplicity. Do you have multiplicity here at 0? Yes or no? Yes, how many times? 2 times. That's really important. Is there multiplicity at 4? No. Is there multiplicity at -1? No. You can write no or once or something like that. That's fine. But why is it important to note the multiplicities? Because you have to graph. What's it going to do here? It's going to bounce. What's it going to do here? It's going to go through. And what's it going to do here? It's going to go through. Uh-huh.
Wouldn't 4 be negative?
Yeah, wouldn't 4 be negative?
And 1 positive?
Oh, yeah, it's backwards. You guys got to stop me. I'm trying to go 100 miles an hour. Okay, this is negative. This is positive. Positive. Right?
No, when
No,
you
like
wrote,
the answer.
when you wrote the zeros,
Oh,
you
so
wrote it backwards.
Oh, jeez. Here I wrote it backwards? Ay, ay, ay. Thank you. Negative, and this is positive, right? Okay, good. I was like, where did I mess up? Whatever, I'm just going along with you guys. Okay. All right, so when we go to graph this, right, very basic graph, where are my points that this graph crosses? -4, right? Where else? 0. And where else? At 1. What were the end behaviors? It was both up. All right, so look, both of the arrows are going up. So what's happening at -4 and at +1? What's the graph doing? It's going through, but what's happening at 0? It bounces. So watch this. When you draw your graph, it's going to go through 4. It's going to touch 0 and go whoop the other way, and then go back up. When you have multiplicity, you'll have a point or two where it touches the graph and it bounces off. It goes the opposite direction. So just make sure you guys are paying attention to that. And again, number 5, I'll post on the on Canvas so you guys have it. I'll post everything all worked out, but just so you guys have it. All right, scoot along. I want to do some more of these.
So for the,
Hold on.
what would the answer be for the multiplicity? Wait, or is that what the answer is when you read like?
When you have, yeah, when you say it's like once or twice or yeah, or none, yeah. Now, guys, on your test, right, you have to understand what the directions are saying. If it says to find the quotient, and remainder. Whether it says use long division, synthetic division, whatever. If it says find the quotient and the remainder, that means what is the answer? What's the whole polynomial and the remainder? Does that make sense? Okay, so I want you guys to understand what they're asking here. Let's do these real quick. I'm going to divide. 2x plus 1 goes on the outside. My inside is 2x cubed minus 11x squared minus 2x plus 2. Do I have any gaps or spaces that I need to account for? No. So we're good to go. So I'm going to say first term into first term. 2x times what gives me 2x cubed?
X squared.
Just x squared, right? So I'm going to put it right here above my x squareds. I'm going to get my subtraction ready before I multiply. And then I say x squared times 2x is 2x cubed. X squared times 1 is plus, everybody with me? Plus x. Before I can go ahead and subtract, what do I need to do? I have to distribute that negative sign. So I'm going to change everything. Change, change, change. So this becomes negative 11x squared minus 1x squared gives me negative 12x squared. What happens to the cubes? They cancel. And then what do I do with minus 2? Bring down my negative 2x. And then we go again. First term into first term. 2x times what gives me negative 12x squared? Negative 6x, okay? Get your subtraction ready. Negative 6 times 2 is negative 12x squared. Negative 6 times 1 is minus 6x. Before you subtract, what do? Distribute, distribute, distribute. What's negative 2 plus 6? 4x. My 12x squareds cancel, and then I bring down my plus 2. So now I say first term into first term. So 2x times what gives me 4x? Okay, plus 2. Get your subtraction ready. 2x times 2 is 4x. 2 times 1 is what? You guys with me? Okay. So before I can subtract, what do I need to do? So distribute, distribute, distribute. What happens here?
0.
Everything cancels. If everything cancels, what's your remainder? 0. What happens if it doesn't cancel? Then you have a remainder. No big deal. So sometimes you have a remainder, sometimes you don't. If you have a remainder, you put it over what you divided by. Questions? Yep. All right. Again, I'll post the answers, so I'm not going to do number 7 because you'll see it. I want to make sure I hit every kind of problem that we're going to see. Let's talk about the remainder theorem. If it says to solve using the remainder theorem, if it says to solve using the remainder theorem, what is the only thing that matters? The remainder. So if I set this up, they're telling me to use negative 2. Let's write out the coefficients. So I have 4. What's the coefficient of x cubed? Negative 16. So then I go 5 and then 9, right? Do I just leave it just like that? Why not?
Have to add the 0.
I have to put a 0 in for x. If you guys don't do that, your whole problem is wrong. You have to account for every single piece, because if not, your coefficients get off. So now we multiply to the corner. What's 4 times negative 2? Negative 8. Negative 16 and negative 8 is? Negative 24. Negative 24 times negative 2 is? 48. 48 and 5 is? 53. Okay, 53 times negative 2. Negative 106, good. And then negative 106 and 0 is negative 106. What's negative 106 and a negative 2? 212. And then what's 9 plus 212? 221. So your answer here, you would write g of negative 2. It's already written there for you. I don't know if I did it or not on the test. But g of negative 2 equals 221. When it says use the remainder theorem, the only thing that matters is the remainder. All right, I put this on here. I'm not going to work these out. Again, I worked it on the review. I want you to understand what the directions say. If it says find the quotient and the remainder, this was just the remainder. If it wants the quotient and the remainder, then it wants the answer to be like 4x cubed minus 24x squared plus 53x minus 106 plus 221 divided by whatever you divided by. Just be x plus 2. All right, just understand what the directions say. If it just says use the remainder theorem, that means all I care about is the remainder. If it says use synthetic or long division to find the quotient and the remainder, that means, ooh, they want the whole answer. That's all that means. Same thing it said on website. All right, let's look at these two, please. Take a picture.